Okay, well, I think we might make a start, everybody.
Okay.
I just want to say, hello, Bidia. Nice to hear your voice.
Nice to hear you. Okay.
So I just want to say thank you to all of you for participating in our webinar about renewable energy pumps. It's really cool to be able to do our second webinar for the WASH group within the ADRA network. And for this webinar, we're actually going to talk about wind pumps and hydraulic ram pumps and hydraulic diaphragm pump. I sent through an email the other day which also included solar pumps, but I realised I was getting overexcited about renewable energy pumps, and we don't have time to talk about solar pumps as well. We're actually going to just talk about the 3 types of pumps this time, and at some stage there might be another webinar which includes solar pumps as well, so that could be a future topic for you all to anticipate and wait for, which would be very exciting. Now Oscar D'Amato from ADRA Pakistan and myself are going to co-facilitate this webinar, and we're really open to having people ask questions as we present, so don't be shy. And I'm not sure about you, but you may not have used GoToMeeting before. You might be more familiar with WebEx, which was what ADRA International used to use, but now they're using GoToMeeting, and I can't see a way that you can sort of virtually put your hand up if you want to ask a question. So what I would suggest that we do for this webinar is that if you do have a question, or if you don't have any questions that you want to ask, keep your microphone on mute, and I can see that everybody is doing that, which is really good. But if you do want to say something, then I would just say unmute your microphone and feel free to ask questions. So Oscar is going to take the first section, which is about wind pumps. And Oscar, I'll just leave it to you and look forward to hearing what you've got to say.
Okay, thank you very much, Victoria. Thank you very much, every one of you. I can see in my screen, Vidya, Esther, David, Rajan, Sahara, and Victoria. Is someone else? We are 6 people.
Yes, that's all that are online at the moment is 6. Yep, that's right.
Okay, great. And good morning from here to all of you. It's a really pleasure for me to be in contact through this webinar or whatever GoToMeeting to share with you. It's only a sharing experience of ADRA Pakistan working with windmill pumps. As you know, windmill pumps are devices to take water or liquids from the ground. I'm trying to remove this, but it's not working. Okay. Most of you are coming up with windmills, different ways that in the world we are used to see the windmills in grinding, to make flour. Also is being used to extract or get oil from seeds for the compression of them through the windmills. And also today is a very huge business, the generation of electricity to the wind through the windmill generators. But also through the times, water pumping was of the most common ways. I remember in my country, in Argentina, for a long time, you can see windmills that has more than 60, 70 years still running. Very old ones, but still running and getting water from the ground. And ADRA Pakistan chose the challenge to use the windmill as a way to get water from the ground, especially in areas that the water is very scarce. We are using that. I don't know if your experience in your countries, the windmill is a common device to get water, or if your offices or your organizations are using this technology, but grass in northern Pakistan is a good experience. That for that we want to share with you a little bit. But let's see a little bit how a windmill works. It's very simple. All of you who are working in was at least once you set one hand pump. The pumping is using the same system that hand pump. You can see here in the bottom of this slide the device of the cylinder with the piston and the valves, two valves here, one here, that are controlling the flow of the water. When the pump with the cylinder goes up, this valve is open and allowing the water to go in the cylinder, and closing this valve in order to get the water up to the tube or to the pipe in order to lift up the water. When the piston goes down, this valve is open in order to allow the water to keep in this container, this section, to go to the other place, and then it's closed this valve. Yes, in order to avoid the water to go down again. And then this cycle is up and down, and then the water is going up to the surface. In the hand pump, you have a manual movement of the rod. This is the rod. But with the windmill, we use the wind in order to make this rod goes up and down, moving the same cylinder. If you have one hand pump, you can replace the hand pump system by a windmill very easily. And then set this towel with the fan and with all the device here in the same place that the hand pump was, and they will use the same hand pump, the same cylinder and piston to pick up the water. That is the device that we're using. We discovered in Pakistan that only one factory was doing windmills. And we said, why not? And then we started doing our project with that, and we had a good experience that we want to share with you. We have some, especially we need to know for the performance, comparing dams and other devices with the device that we are using, this the windmill. And you have different sizes, also used according to the depth of the water that you can take. And we have here, we have fans with 70 feet of diameter of the propellers, 8 feet, 10 feet, that, those are the most common in the market. In our case, in Pakistan, we are using this 10 feet because the level of water, the depth of the water are very, very high. And then we are using this this fan or this windmill, the 10 feet. You can see here in the table the level and feet of the elevation of the water. If you have 2 million liters, the water from 15 feet, 30 feet, you can use an 8 feet. If you have less than that, you can use a smaller one. That will work very well. But if you have deeper and deeper, you can use bigger ones. And we can see that up to 128, even up to 150 feet, you can use this 10 feet propeller. Of course, we value also the diameter of the cylinder and the piston inside. And also the pipes, the lifter pipe, take water from the cylinder to the surface also will vary according to the diameter of the cylinder. But the question is, how much water we can take from the ground. And you can see here also the quantities. Using that, we are using more or less in this scale, 95 feet deep, 75 is the most common depths of the water that we are getting, and we are getting 2,400 liters, 15,000 according to the place and the yield of the borehole. You can get water. Other question is, what is the cost? Because that is one thing that I say we are looking for. What is the performance and the the cost of the devices that we are looking? Well, it varied in the market. That was checking in the internet in different countries, and varied between $2,500 to $6,000, depending on the size of the windmills. In our case, the local one that we are getting in Pakistan cost us $4,500. Now we are importing one from Argentina with a little more design and more better technology. We just got one in order to test, to see, comparing with the local one, if the performance is better. We're thinking to import those in order to use them. But if the performance is more or less the same, it's pointless to bring other windmills from abroad. Maybe you have, as Victoria said, you have some question, please be free to write on your voice and then ask any question.
Actually, Oscar, I've got a question.
Yes.
Just
yes.
In terms of the price that you paid for the wind turbine in Pakistan, can you just go over what was the size of that wind turbine that you got for that money, and how much, like where it would have fit onto this table of performance?
Yes, we are using the 10 feet fan or windmill. The diameter is 10 feet. Means that the propeller has almost 3 meters one side of the diameter to get the wind enough in order to move the propeller and to move the piston. And we are getting more or less 2,400, between 15 and 2,400 liters per hour in our windmill experience. Deepest, the table deepest, we are getting less water because the energy, the effort of the windmill is higher, and we'll get less water as well from the ground. And the cost, yes, I said that our cost is more or less $4,500 with everything. We are talking everything with the device, the installations, the borehole, everything to set one windmill here in Pakistan. We are expecting, if we bring this from abroad, will cost $6,500 to set one windmill.
And,
yes,
and Oscar, so,
yes.
Just to ask another question, so the litres per hour is the 2,400 or 2,400.
Yes.
And I'm just curious to know whether the wind is consistent through the day or whether it changes. So is that like a maximum flow per hour, or is that like an average over a whole day? So in your experience, what would your flow rate be per day?
Yes, we will see that to set a windmill has their pros and cons as well. Yes, this is an average. This is set by the factory. This amount of these quantities are set by the experience of the factory. But our experience is more or less getting that. Why? Because it depends in the quantity of wind that you have. You can get more, you can get less. If the timing of during the day, sorry, the timing of over the day of the wind is constant, you will get a constant flow of water every day. But there are days that maybe the wind is only few hours a day, and then you will get less water. And then you need to be doing calculation of, okay, in this time, in these 3 or 4 or 5 hours during the day, how much water I can get, comparing to the water that I need. In our case, we are setting these windmills in areas that 24 hours a day there is wind, enough wind to move the propeller. There is some time during the day that the windmill runs faster because the wind is faster. But in this case, in our case, 24 hours a day the wind is flowing. But yes, as you say, it will depend of how many hours per day you have already. And also we will see in the during the presentation that the minimum requirement to move the propeller is 15 kilometers per hour. The wind should have a speed of 15 kilometers per hour. Less than that will not be able to move the propellers, and then the rod will not go up and down in our cases. But our experience is we're getting 2,400 liters per hour as an average. It's enough water for doing a lot of things. Okay, I'm trying to move the next slide. It's not moving. Okay. You can move for me. Okay. Okay. And then you can see the advantages and disadvantages of this using windmill. Advantage is like in a very simple technology comparing to the solar system, fuel system that you can spend a lot of money, maintenance, and that. It's a long lasting. Even for the Pakistan product, Pakistan windmill, we were visiting some windmills that are working for more than 30 years. And the factory says we can guarantee 20 years that this windmill will not have any problem. Of course, there is small maintenance to do, but it's also low. You can see $10 per year, the maximum that you can spend. It's very easy to be repaired by the beneficiaries, because when we set the windmill, that's the same way that the hand pumps, we teach them how to change the parts that they are needed. And the high performance of this windmill, because 24 hours pumping, comparing to the hand pump that is only pumping when you move the hand pump by yourself. This is pumping all along the year, allowing you to keep a lot of water. And also has a auto protection, self-protection against high winds. Let's say a very high wind or a storm is coming, the windmill is stopped and closed, shut down, and then it's protected against the destruction of the wind. But also has some disadvantage. Need wind, and that wind should be major or more than 15 kilometers per hour to move the propellers. Without that, you will be the windmill will be pointless. Also, cannot get water for more than 120 feet deep. Beyond that, maybe at 150. We have experience to 150 is a little bit, but not with the performance in less deepest. But that is a restriction as well. Maybe with a solar panel, with a submergible panel, you can get water from deepest places, but the windmill has that restriction. And also because the space and the wind that need, it's very difficult to set the windmill in the middle of the city or the town, where everything, the houses, the trees are making a barrier against the wind, and then the propeller will not move. Also the space, because the base has a surface to cover, and maybe in a city it will be a little bit difficult to set. But for rural areas, there is not. And let's see the next one. The experience of us in rural areas is very interesting and very successful, because all the people, small farmers, families on the ground, they have their own places. Okay, I'm trying to move the next one. I don't want to do a long dissertation. It's not only sharing and giving you the chance to make your own questions. I hope some of you has experience working with windmills. Victoria, can you move the next slide, please?
Oscar, just a question.
Yes.
When you say that it auto protects against high-speed winds, do you have a threshold as what could be the hold? Is it about 150 kilometers per hour speed, or is it even more than that?
Yes, when the wind goes up to 60 kilometers per hour, the tail of the windmill is start turning against the propeller. It has an automatic way to shut down, to close, to stop working, and then that protects. If the windmill alone gets 100 or 80 or 90 kilometers per hour, the fan will be destroyed. So much revolutions, and then will be destroyed. The same happened with the electric windmill or generators, electric generator windmill. Maybe you saw some cases, and that windmill explode because couldn't control the speed, and later on because the high revolution of the propeller make the windmill destroy. The same case in our windmills. It has an automatic device to control this problem. Okay, now you can see different ways to use the windmill. I can tell you, I only thought that, okay, the windmill is only for pumping from one borehole to the surface, and that's it. But when I visit factories and where I was talking with them, I discovered many ways to use the windmill. It's not only a hand pump for ground. If not, you can, as you see in this picture, this could be a canal, it can be a lake, can be a forest, anywhere that you can pass from that place to yours. It can be a river that is close by, or somewhere else that you can pass from there. It's not a deep one. It's a reservoir that you have close by. In this one, you can see also a river here that is coming from the river to fulfill one container for cattle or for animals. And for this, also you can get a device that will shut down the windmill pumping because the container is already full. And this is the traditional, and you're right, the bottom right. This picture is pumping from a borehole to fill the tank for your home or for your use. Also, you can set a chlorinator, a device for include chlorine to purify your water. And the next one, we can see also another. Okay, thank you, Victoria, for changing the lights. Also, to elevate water in high places. Also using a system with a pullman, a line here, a vacuum line, and a bubble up to. That's a system. We can use the whole windmill with a system to lift water that's higher altitudes. And that is used for communities when the river is down and the community has a tank field. You can pump with a windmill very easy to fill those tanks and then later on be distributed. In the right one, you can see in this case that one windmill is pumping water from different boreholes. In this part you have boreholes. In this case, 8 boreholes. That you can build a network in order to use one windmill to use all those boreholes that maybe has is very small, means that you can get a few water from here, but in the combination of many of them, you can produce water that you need for making maintenance pipe. We were discussing with the government in Pakistan in the area that we are working is desert areas. In many of the places they have salty water, but 3 or 4 kilometers far we are setting one windmill but pure and sweet water. And then we're making the plan for them is to set the windmill there and pumping the water through the windmill, pumping the water to that community that is 3 or 4 kilometers far. That can be used for fuel and the windmill. It's many, many ways to use the windmill to meet our needs. Okay, we will pass the next one. Thank you, Victoria. Okay, talking about the maintenance, we talk a little bit, but it's so cheap to maintain as a hand pump. You need to change only the washer of the sealing rings that makes in the cylinder with the piston and valves. That could be $2. We are talking about Pakistan. It's only the sealing. It's very cheap. The community can do the change, and then it's very, very cheap to maintain. Some of the windmills use a lubricated motor with the gears inside, and then they use a little bit oil, 1 liter of oil. Here we can spend $2 on that per year. It's only the maintenance is once a year, and you see that is 2 and 2 would be $4. We say $10, but we can save money also from that calculation. And also the windmill can last more than 20 years without major maintenance. And the maintenance can be done, as we say, by the community as well. It's very, very cheap to maintain one of these windmills. Maybe time to time only painting the windmill if the material is not galvanized. If it's iron, you can use painting time to time for covering with rust. But that is all what we need to consider for the maintenance of the windmill. We can say it's the same maintenance that the hand pump, but the production of water is too much different. Okay, if you have some question about this area, because always when we use technology, we think in maintenance, the cost of maintenance. We were checking with experiences in solar plants and other devices that are more expensive, especially with the kind of community that we work in the interior of the country, that they are poor people, they don't have a lot of money, and then if some device is broken, they should be able to replace it, because you cannot commit the whole life to your organization to take care of that. And that's for that we discovered that hand pumps or windmills are the most suitable for the community in terms of spending money in repairing those devices.
Just a question, Oscar. The maintenance costs that you've got here, are they based on ADRA Pakistan's experience, or are they based on information that's been provided by the pump supplier, the windmill supplier?
Yeah, that is our experience here. But the cost of the devices, the washers or the sealing rings that have to be changed, are very cheap everywhere. And then we are sure that no matter if it's $4 or $5 or $10, even $20 per year, and to maintain a device working is very cheap as well. Will vary, of course, country by country, but the difference will not very much. It will be very much affordable by the community in doing that. I don't know if in your case in New Zealand, how much will cost one washer? Maybe $5? I don't know. But it will not be a huge amount that will not be able to be afforded by the community who is using the windmill in this case.
Yeah, that's right. It is a low cost for the washers. Can you also talk maybe about the maintenance requirements for the actual tower and the blades of the windmill? Or do they, like what materials are they made from that makes them last so long?
Well, the materials are in some cases galvanized, and then they will not get rust. the whole material, the whole propeller, the whole system is made by galvanized iron beyond the machine itself. But it's, as I was saying, the material of the towel or the propellers are not galvanized or a product which is against protected against rusting. You can paint. You can paint every 5 years maybe, depends on the painting that you are doing, every 5 years or more. We saw windmills that more than 20 years without any painting anything. Okay, in some part were rust, but not much. But the maintenance is very, very low cost, no matter the material that is done. I think this will go down in terms of cost, efficiency, cost effectiveness is a very, very important to consider in this case. Okay, if we can pass to the next. I want to show you some experiences about ADRA under Pakistan, because until now we were talking about the device itself. In ADRA Pakistan, we run this, as I mentioned, in mountainous areas and very arid areas, where the water is not in the surface. There is no stream, there is no river, there is no pond, no lakes. It's a desert area, but the water is there. And for every, we calculate that every device, every windmill will provide enough water to maintain between 25 and 30 families in one community. The same calculation that we do for handpumps, but in this case we are calculating the same, thinking that we will use the water for other purposes for those 25 to 30 families. It's not only for cooking and drinking. Will be for cooking, drinking, washing, watering animals, growing vegetables as well. And then for that, here you can see, okay, the 3 steps is the drilling. We have our own drilling system, our machines to make the drill. And then below in the left bottom, you can see the moment of setting the propellers before setting in the top. And in the right you see how they are setting the propellers on the windmill. And you can see here two water tanks. And then there is a big water tank here. These 2 water tanks are a purpose. The first step to fill with pure water. The community can use this 500 liters tank each with clean water for cooking and drinking. The overflow of this will come to the big tank to do later on to be used for farming, for watering animals, whatever the other use the community want to do. Those are the use of the windmills. You can see here also there is one. And then here you can see on the left, there's setting there. Okay, it's not setting because it's already working this. It was the water control in the tail. And then you can see here one water tank is 10,000 liters that is filled in a few hours. That the people use the water. You can see the right. This is the overflow there. Yes, the origins of this water tank, and that is going to water all these gardens or home gardening or farming area. We are very, very happy with this, and you will see that using these windmills get you a lot of good outcomes with it. But the matter is, what are the criteria that we use for setting a windmill? This is based on the purpose of your project. In our project, we set windmills with especially focusing allowing the families to do farming, especially growing vegetables and fruits, because we're combining wash with food security for those communities. Communities in the desert, normally they eat more meat than vegetables and fruits. And in this way, we are providing the opportunity for them to grow vegetables for their diet. And then the criteria we use, it should be, the need of the community should be more than 5,000 liters per day, the minimum. And there is enough wind. We already talked about this. There is enough wind on the area for moving the propellers beyond 15 kilometers per hour. The land is available for setting the windmills, and the owner of the land is allowing us to set the windmill for the community, not for their own use, not for the community. The community has farming space. That land can be used for farming, and the community is willing to do farming. If they are not willing, we don't decide in setting one of them there. Those are the main criteria that we use in order to say, okay, this community we will set a water. Normally, the government gives us, we need water in this community. And then we do our baseline in those communities to decide if in this community or that community we will set our windmill or not. That's the criteria that we use for our farming, to decide. And here are some outputs of our project. And you see in this place, the windmill, before this time only was this tree and the bigger trees, because this has 2 years already of, this windmill has 2 years already there. In this case you can see the products already, papayas that were not there. In this place there was nothing before. Now they are growing papayas, they are growing chilies, they are growing sugar cane, they are growing tomatoes, so many different kind of vegetables and fruit. They grow mangoes now, they grow trees of mangoes, chicos, that's a traditional fruit here, papayas, bananas, and here, okay, here you can see also another farming area for another community that they are growing many vegetables. This fruit here that you see, this plant, they are used for make flour, to make their traditional chapati that they have as a bread here, and many different kinds of vegetables. And this is the tank, the 10,000 liters tank that they fill every day. First, they fill these two, as I mentioned, and the overflow of the tanks goes to fill this. Means that the community has saved first 1,000 liters of clean water. Later on, the water goes here. Okay, I think we are coming to the end. For the next one, the lessons that we learn. And we learn many lessons, but among them, these are the main ones. The villages and rural communities are willing to grow vegetables and fruit for their consumption. That is one thing that we discovered. Even they didn't have experiences before because the land is very arid, very desert, no water. But once they have water, they are willing to do that. And also with using this windmill, we are getting the attention of other communities. And they're getting jealous of, oh, we want to have a windmill as well. And they are, later on, talking to the government, we want those windmills that ADRA is doing. And the government is requesting us and funding those projects as well. And also we discovered, okay, the hand pump was a point of gathering, especially the women and children together at the time of getting water to take home. But in this case, it's not only that one. With the windmill, the whole community is coming together to work together for a longer period of time. And this is giving us a good chance of doing other activities with community, health, hygiene trainings, sanitation training as well, working in different other areas, because the people now are working together more they are getting used to being together when they are working for farming. Those are the main three lessons that we are learning, and we are exploring now new ways to use this lesson for our future projects. I think this is the last one. I really appreciate it. Okay. That is.
Thanks very much for that, Oscar. Yeah, thank you.
Thank you
just
very much,
want
everyone.
to ask if anybody has any questions for Oscar while I just try and swap over what we're doing. But yeah, if you've got any questions, please please feel free to ask Oscar any questions you might have.
Maybe okay.
I have one question, Oscar. Rajan here.
Yes, Rajan.
Because we are also looking at some innovative techniques, how we can do, I mean, although windmill is an existing technique that we have. I just want to know the feasibility of, using this in extreme drought conditions. How do you think whether it's feasible or it's not at all suitable at all?
I think there is no problem, but you need to consider two things that we already said there. The criteria. If there is enough wind in those areas for moving the propels, and you need to know the deepness of the water. If the water is beyond 120 or 150 feet deep, will be impossible to use the windmills. Will not be able, or the performance will be very low. But the main thing that I would say, check with the geologists or in some way to know the deepness of the water, where the water is, and then decide how much, measure the wind that you have in that area. If you have those two, you can set a windmill, and how many hours per day you have wind in
all right,
that area.
thank you.
No problem. I think there is no problem.
Oscar, I have a question, please. This is Sahara from ADRA New Zealand.
Hi, Zahara.
Hello. I was wondering if you would have your presentation available to us through email or some kind of link.
Yes, I think it also will be posted in ENET, and Victoria will be distributing this, I think. Are you working for ADRA? Sorry for asking, Sahara. Are you working for ADRA?
Yes, that's correct. For ADRA New Zealand. Victoria is my director, and I'm the International Program Manager. Yeah.
Okay,
it's
good.
Nice to
yes,
meet you.
she's going to make available this presentation for everyone.
Yeah, so I'll put the presentation up on ENET so that everyone can have access to that, and yeah, we'll send out some instructions as to how people can access ENET and whereabouts in ENET they can go to find where the presentation would be found.
Yes, what about those who are not members of ADRA? How they can get this presentation?
Yeah, that's a good question actually, and something that we've talked about as well, how to make the presentation available for those who don't currently have ADRA email addresses or are not ADRA staff members. So what we could do for that is I will be making an MP4 file of this webinar, and if there are people outside ADRA, then just contact either myself or Sahara, and we can either upload it onto Dropbox or put it into some forum that is accessible for those who are outside ADRA.
Great. Okay, again, thank you very much everyone for your attention. For any question, please, you can write to our group.
Vidya, I think might have a question as well. Go ahead, Vidya.
Yeah, hi Oscar. Thank you for making wonderful presentation, and I'm sorry that I was on and off with my internet and I was going to ask the same question that Sahara asked, but I'm sure that the presentation will be available. But we have no experience in this in Nepal, so it looks very promising, and see how it can, you know, work in the future. But that looks very interesting. Thank you for the presentation, and I hope that we'll get, as you have already said, it will be available to us. And if we want to work further, maybe we'll contact Oscar on that. We might need your help, Oscar, if we decide to work on this sector.
And just another point to add is that in the MP4 file, it will also include the audio and any questions that have been asked throughout this webinar. That's all being recorded, so that's going to be part of the file that people will have access to.
Great. Okay, if there is not other question, thank you very much again, and Victoria, the rest of the time is yours.
Thanks. Yeah, so I'm going to be speaking about hydraulic ram pumps and hydraulic diaphragm pumps. And the first one I'm going to be talking about are hydraulic ram pumps. Now these are pumps which use flowing water to generate movement inside the pump, so that we can make water flow uphill without the use of electricity or other external energy sources. And the first type of pump I want to talk about is a ram pump, or hydram, sometimes they're known as well. And I've actually got a couple of video clips in my presentation which may or may not show up on your screen. It depends on how good your internet is where you are. So if they don't show up on the screen, let me know, and I will make them available as a separate file, or this one that I've got open here is actually a YouTube clip, and I can make that URL available for the YouTube clip. So I'm just going to press play now, and let's see what happens. You should be able to hear somebody explaining how it works. If you can't, let me know and I'll talk you through it. So I'll just wait for the view to catch up with us. So basically, as the water comes down here, it's actually flowing initially through the waste valve, and then once that closes, it pushes the water up through into something called a pressure vessel, and that has air in it which can be compressed, and then as that air is compressed, it eventually has enough pressure in there to shut this valve, which then allows a little bit of water to flow up the delivery pipe. And when I show you a little bit later on the case study, you'll be able to see quite easily that there's water flowing out of the pump through the waste valve, and there's a big thing on top of the pump which is the pressure vessel, and you'll be able to also see the drive pipe and the delivery pipe as well. And you'll also notice that there seems to be a lot of water that's not being pumped, that it's passing through the pump and ends up back in the stream, and that's because that water is being used for its energy and its motion rather than its delivery. So I just want to talk you through a case study that we've used in Vanuatu. It's called a Williamson ram pump, and it's been installed on the island of Tanna. So hopefully you can see a Google map image there, which looks like it might be just coming up on your screen about now. And that actually shows you, this is where Vanuatu is, for those of you who may not be familiar where the location of Vanuatu is, which actually has lots of different islands, and one of the more southern islands is called Tanna. So we're focusing on the area of Tanna. Just wanting to check that you can still hear me.
Yep.
Yep, excellent. Thanks very much for that.
Yes,
I can.
very well.
Great, thank you. I got a little message that came up saying you might not be able to hear me, so I was just asking. So here we've actually got the first component of the ram pump system, and this particular ram pump, this is quite typical on other ram pumps as well, but this particular ram pump has what's called a surge tank, and this is the surge tank here. And the surge tank collects the water from a source tank which is outside the area of this photo, which feeds water through the delivery pipe to the surge tank, and then from the surge tank you've got the drive pipe. Now you'll notice that that's PVC pipe, and that pipe there, actually that's stainless steel pipe, but sometimes it can be galvanized pipe as well. And the reason why this isn't PVC is because the pressure from the, it's actually like known as something called water hammer. The back pressure from the pump when the valve slams shut inside the actual pump is really high. And if that was made from PVC, it wouldn't take very long for it to split, because it just couldn't cope with that pressure wave which comes up from the pump itself back up to the surge tank. And this thing here is actually an overflow in the surge tank. Now continuing to look down, there's the drive pipe which feeds down to our ram pump. And you can see there's the drive pipe, in case there was a bit of a delay there, and the ram pump. And you can see that there's actually, at the moment, the valve is open here. This pump actually is slightly differently configured to the diagram that was on the YouTube, because there's actually a pressure release valve which you can see is going off at the moment. There's water sort of shooting out the back of the pump, as well as the intake valve, which actually opens and closes, and as that opens and closes, then water's also escaping here too. So this is this natural stream bed to the side, and all of the excess water just flows straight back into that stream bed. And so we've also got the delivery pipe here. So that's the pipe that goes up to the tanks. And here is a different pump, but you can see again here's a drive pipe which actually goes up to an intake structure and a source tank, which is just out of view here, but it's really long. This particular drive pipe would be about 40 metres long, so they do take up quite a big area and footprint in the bush. And yeah, this particular drive pipe here is about 40 metres long, so that's something to think about when you're planning the location of these pumps. Again, you can see here, here's our intake drive pipe, and then that's the actual pump system. So it's quite a big system, probably weighs about 70 or 80 kilograms, and there again you've got your delivery pipe which goes up to your water tank. Now I am going to attempt to show you a video of this system, which may or may not work, but if you can't hear it, or if it just looks like a series of photos, don't panic. I can upload this video clip for you. And one of the things you'll notice is the banging noise. So that's showing the intake box there, and then the surge tank. So there's a piece of plastic they've covered the surge tank with just to stop the surge tank from emptying out. They wanted to raise the level. You can actually also... Yes,
that box is a pump?
That box is the surge tank.
Okay.
So that's just holding water.
Okay.
So what we've got there is if you just wait a second, okay, so if you can see there's a valve here. Can you see the mouse? I think you'll be able to see the mouse there pointing to a valve which they've actually got just so slightly shut to stop the source box, which is upstream, from emptying too much, and they've actually covered this up to just raise the water level in here. Because they said that it doesn't actually, shouldn't really be there, but apparently this box, when it's down at that level, doesn't have enough pressure to actually operate the pump. So they've just put a piece of plastic there to raise the water level a little bit inside the surge tank. So that lid comes off, and all it's doing is providing enough water to feed down that dry pipe to make the pump operate. Now here's another video clip which again may or may not work particularly well, but it's actually just showing the pump in operation. And the other thing with these pumps is that they are quite noisy, which isn't usually a problem, but if you had it somewhere in an urban area, you'd be wanting to think about the noise. That's the drive pipe coming into the pump. So that rising main, or that delivery pipe, had been installed initially with a PN 12.5 pipe, which means it can cope with a pressure of 125 metres, but because it was splitting, they replaced it with a PN 16 pipe. So the back pressure from the tanks was enough to actually make that split, even though when we had done our original levels, it seemed that a PN 12.5 would be fine, but it wasn't. We had to replace it with the PN 16 pipe. So I just wanted to go through a few advantages and disadvantages of a ram pump. So the advantages include that it uses the motion of flowing water to operate the pump. So you don't have to pay for petrol or diesel or electricity to run the pump. And because the water is actually flowing for constantly when it's flowing, like it's not just during daytimes or when it's sunny, it actually can pump for 24 hours. And once installed, the operational costs are pretty low. And it's an energy efficient way to pump water, which means that the energy required to actually pump that amount of water is quite efficient, even though only 20% of the available water is actually pumped. So 80% of the water is just used to operate the pump, and only 20% of the water that is used, that goes through the pump, actually gets pumped up the hill. And having said that, you can actually use a different source for the operation than you use as a source for supply. So that means that you might have a good water source which is great for operating a pump, like a river, but it's dirty. and then you may have a nearby stream or spring which has clean water, and you can actually pump that into, or use that for pumping, which is different than the actual water that you use to operate the pump. And if you're using robust materials like galvanized steel or stainless steel, then the pump itself has a long lifespan. The things that you have to be mindful of include that you need to have really careful data collection to make sure that the stream flow is sufficient to operate the pump, because if you've got a stream that either dries up or reduces its flow certain times of the year, then you are going to have a reduced pump volume, and you're not going to get as much water pumping into the water tanks as you hoped for. So that's actually quite a tricky thing to get, because often you may only get one or two chances before you select and size and choose the pump to get data and flow data from a stream. And in reality, it would be really great to get data from the dry season and data from the rainy season, and maybe over a period of years, but in a lot of cases it's just not possible to collect that data before you have to size and design the system. Another challenge is that the initial installation costs are comparatively high, and by the time you freight pumps in and pipes in that situation that I showed you, that actually had two pumps in the same area. So one was downstream of the other, and we were able to use the water that discharged from one pump and then feed that same water into a second pump. So basically the 80% of water that I was talking about that's used for energy almost got used twice, because it actually went through two pumps, which is quite good, but you need to, there's obviously a cost associated with doing that. You need to plan carefully to make sure that it's the right solution for that location. You could see that the drive pipe is very long, and particularly in a situation where you have two pumps, you've got pretty much twice the length for that drive pipe. So you need a big footprint, and it needs to be straight. That drive pipe has to be in a straight line on a very specific angle to make the pump work. So that all comes into consideration when it's time to choose your site location and your source location, and considering how much you need to lift the water. You have to decide whether that's actually going to be the right solution for your situation. Another challenge is that by its nature it has to be located close to running water. So during periods of rainfall, then the water has to, if it's going to flood, then the pump is at risk of being damaged due to floods. And we've had some issues with some of these pumps being damaged after or during a flood, particularly the surge tank, which is a little bit lighter. It's only made from sheet metal and maybe more easy to damage. So here's some pump costings, and these are as per the case study that I just talked about. So there were two pumps there. One of them is a 400 and one of them is a 250. They have different diameter drive pipes. One had a large diameter drive pipe, one had a smaller one. And for a pumping head of 20 metres, which means you want to, say, pump up every 20 metre lift, if you've got a drive head of 1 metre, you can pump 20 metres. And you would get about 13,700 litres per day. So if you've got a drive head of, say, 5 metres, then you would be able to pump up 100 metres and get about 13,750 litres per day. And the cost for that particular pump is $13,000 US, which includes the pump and the drive pipes and the connecting pipes and the surge tank, but it doesn't include freight. And then for the smaller, slightly smaller pump, for the same sort of operational and driving head, you would get about 5,000 litres per day, just over 5,000 litres per day, for a cost of about $8,000 US, excluding freight. Now, is somebody sending me messages? I will just ask. Oh, no. So, any questions about the costings or anything so far?
One question, Victoria, it was not clear for me. Distance or the height that the water should be, okay, the column of water that should be hitting the pump, regards of the distance or the high levels that the pump will rise the water. That is not because it's a pumping head. What does it mean, pumping head? The pump should be at that.
Yeah, so what that means is, so the driving head is the difference in height between the surge tank and the pump.
Okay.
And the pumping head is the difference in height between the pump and the delivery tank, the storage tank where you're actually going to pump to. So if you had... Yeah, go ahead.
Sorry. It means that 1 meter of difference between the water tanks and the pump is 1 meter. The column will be 20, the water will go 20 meters high?
Yes. So for every 1 meter, you can lift 20 meters. So if you had, say, 5 or 6 meters of driving head, then you could lift, you know, 100 or 120 meters between the pump and the tank. So these pumps, there are lots of different types of ram pumps. Quite a few of them are much smaller than this, so they have a smaller lifting head or pumping head. But these ones are quite a significant size pump and actually have a pretty good pumping head. And that's one of the advantages of them, is that they do have a good pumping head. And that's what I meant by the efficiency is pretty good. So for the amount of driving head you've got, you can pump up to a tank which is comparatively high, even though you're losing 80% of the water, if you like. It's going back into the stream that you actually pump, if that makes sense.
Yes, very much, very much.
So some lessons learnt. From our experience in Vanuatu, manufacturers tend to be over-optimistic how much the pumps will pump, and also about how long components will last. So I think just about in every renewable energy pump system that we've put in place, the pumps actually delivered a bit less than what they have said, the manufacturers have said it would pump. And even with these pumps, they're quite a robust pump, but we've still had some componentry failure, which the manufacturer has been pretty good about replacing, but it's still a consideration. I think that they are over-optimistic. The delivery heads, which is the head difference or the elevation difference between the pump location and the tank location, if they're measured with a barometric GPS, they may or may not be accurate. There's a level of inaccuracy for that, and that may have an impact on how much your pumps will pump as well. One of the other lessons we've learned is that you need to allow plenty of time for installation and commissioning and optimising the system. So the day that the pump actually gets running for the first time isn't the day your work is over, that there still seems to be optimising, troubleshooting, commissioning little glitches that need to be ironed out before the person installing it can consider their job to be set up. And in our case, even the manufacturer who's been there to install it has taken longer than he thought to set the pump up within the time that he originally gave us to do it. And I mentioned before that the ram pump components, such as the surge tank, can be damaged by flooding. We've had actually also small holes that have developed in the drive pipe. We had one drive pipe that was galvanised, and there was a tiny little hole that developed in that galvanised drive pipe, which meant that air leaked into the system, and once we got air into the system the pump wouldn't run, and so we had to replace that pipe, and we ended up replacing it with stainless steel pipe, which of course is a lot more expensive than galvanised pipe. And when you consider that you've got a long length of pipe and it's maybe 100 millimetres in diameter, that can add a significant cost to the overall system. So operation and maintenance. If the pump becomes submerged in water, such as when it floods, it needs to be manually restarted so that the pressure release valve or the waste valve can be reactivated, and then the pump needs to be started in that way. The intake structure and box needs to be checked and cleaned out every so often, and particularly after periods of flooding. And the surge tank will need to be monitored after floods to check for damage as well. There's a spring and a polythene bush inside that pressure release valve where all of the water was pouring out, and that's subject to quite a lot of pressure, and that may need to be replaced as well. The springs are about 12 or 15 millimetres, like the gauge of the actual spring metal is about 12 or 15 millimetres in diameter. So they're quite heavy duty, and the actual spring itself would be about 150 millimetres in diameter. So they're quite a substantial spring, but they still may need to be replaced. And there's also a diaphragm inside the pressure vessel which may need replacement. We haven't actually had to do that. We've had no issues with the springs or the polythene bushes or the diaphragm valve, the diaphragm inside the pressure vessel, but they are moving parts, and as such they may need to be replaced at some stage. The rising main or the delivery pipe needs to be checked periodically for leaks. And that brings me to the end of hydraulic ram pumps. Any questions on that before I move on to the diaphragm pump component? Okay, well let me move straight on to the hydraulic diaphragm pumps. Now there's different sorts of these around the place, but I just want to focus on one particular type, and it's called a Glockerman pump. It in many ways is pretty similar to the ram pump because it's also using flowing water. The ratio of water that's pumped versus the ratio of water that's used to actuate the pump is pretty similar to a ram pump. And here you can see that we've got a drive pipe just like the other one. We've got our pump body, and we've got our delivery pipe up to a tank. And we've got, but it is actually less complicated, and it requires a small head, like the difference in height between here and here can be much lower. And also, interestingly enough, it's not too critical for this drive pipe to be either straight or on a specific angle, unlike the ram pump. But the amount of water that it pumps and its lifting capacity, so the difference in height between here and here, is also smaller than a ram pump. So I'm going to try and play a video, and I'm actually also going to try unplugging my earphones, thanks to a suggestion by Sahara, to see if we can maybe hear the audio at the same time. So let's see how it goes. Flick me a little message if you can hear the audio.
The Glockerman water valve.
So can you still hear me?
Yes, yes, yes.
Very good.
Yes.
Okay, and I just plugged my microphone back in.
Yeah.
Fantastic, thank you for that. So as you can hopefully were able to hear and maybe see some of the pictures or a little bit delayed movie on your screen, but at least hear the audio, that as the water comes in through the drive pipe here and enters the main pump chamber, it actually compresses that black thing as the diaphragm and compresses that spring, and then as the spring then rebounds, it actually creates the push motion through the delivery pipe here, and then you've got the same release idea, similar to what we saw with the ram pumps, is occurring here. So we've actually got a cast iron housing here, and that's all bolted together, and then here are the adjustment nuts that they were talking about in the video as well. And with these you can actually configure multiple Blockman pumps in series so that you can have more than one set up, which is the situation here, which is what we've got actually we're going to ultimately have in this situation, is have two of them set up in series. So to the right is the intake structure, and you can see that it's like a weir in a stream, and one of the drive pipes obviously has a bend in it, which doesn't matter too much because it doesn't have to be a straight pipe. And also the head difference between this water level here and the level of the pump is only about 1.2 metres, so it's a much smaller drop than for the other hydraulic pumps, but that's fine because this pump will operate on a very small head. So the advantages of the Blockman is obviously it's using the flowing water to operate, similar to the other one. Once installed, it has low operational costs and obviously can pump water 24 hours a day. Similar ratio between water pumped and water required to activate the pump, but the required drop in head is quite a bit lower. The disadvantages of the Blockman, quite a few of them are similar to the disadvantages that you might see in another hydraulic pump. Like you still need to collect data, you still want to make sure that your stream has sufficient flow all through the year to operate that pump. The volume of water pumped is lower. Now what I mean by that is that it's a lower volume of water pumped than for, say, a ram pump. It obviously needs to be located close to running water, so is therefore at risk from damaging floods. And the other thing we did actually find was a bit of an issue is that it is quite a small pump. It's only about 50 kilograms and therefore is at risk of theft or vandalism if left unsecured. And the diaphragm might actually tear, and I'll show you a photo in a little while, if the housing bolts are not done up in the correct or are over or under tightened. So the initial installation costs are quite low compared to, say, a ram pump, and the angle of the drive pipe is unimportant compared to, say, a ram pump, and its footprint is much smaller, which is actually quite handy if you've got a tighter space to fit it into. The source water, similarly to the ram pump, can actually be different than the source water for supply. So you could have one location of water for operating the pump and a different location of water for actually, for your drinking water or whatever. The other thing is that just in terms of, I'm not sure if this is an advantage or a disadvantage, is that the maximum pressure entering that pump is only 1.8 metres. So if you've got more than 1.8 metre fall between your source and your pump, you would have to put a stand pipe or a vertical open PVC pipe upstream of the pump so that it overflows before the pump gets overpressurized. And the level of the top of that pipe would be 1.8 meters above the pump itself. So tractor tubes can be used as a replacement, but they're not as thick as the original diaphragm, so it's unlikely that they're going to last as long. So the pump that you just saw a photo of is a 320, a Glockerman 320, and it has a 100 millimeter diameter bore, which means the shaft inside the pump is 100 millimeters in diameter. It's not the diameter of the pipe that goes from the pump to the tank, and it's not the diameter of the drive pipe. There's actually a bore inside that pump, which is 100 millimeters. Now Rajan's saying he can't hear me. Is that any better, Rajan? Can you hear me now? Is there any difference there? So the amount of water that that pump can pump in a day is 4,450, which is obviously a lot slower or lower than for a ram pump. And the pumping head's also lower, like the elevation difference between the pump and the tank is lower. And the driving head is also lower. So for 50 meters delivery head, or the head between the pump and the tank, then the driving head's also 1.2 meters. And then the cost actually is also lower as well. So it's only about $1,600 US dollars for that pump, excluding the freight. So you can see in your screen in a minute, you'll see popping up a few issues that have been experienced with the pump in Tanna. The image on the left actually shows some pitting, which is from grits and things like that getting through the system. And also maybe the adjustment was probably not quite set up right at the first installation, and it's allowed that cup to rub on the piston inside the pump. And then the middle photo is actually a diaphragm that's split, and it appears that this is because the bolts may be done up in a regular pattern, maybe in a clockwise motion, rather than doing up one bolt, say here, and then the second bolt on this side, and then another bolt down here, and then a fourth bolt up here, that it's actually possibly been done up in some sort of a circular motion. But what's interesting is that those splits there have been repaired with bicycle inner tube repair kits. So they look like they've actually done quite a good job. I'm not sure how long, this was only done a few weeks ago, so I'm not sure how long that's going to last. But it was quite good local initiative, and just sort of to give it a go and see how it actually goes, because the place where these have been installed is quite a remote location, so they don't have too many resources at their option. But one of the lessons that we did learn is that we need to ensure that there's additional diaphragms and rubber cups are purchased, so that when things do go wrong, they can actually have them at hand. We did think they would last more than a few weeks, which is what was happening here. We thought we'd have a bit more time to set them up before we needed some replacement parts. Now the drive pipe actually in one location was installed with about 3 90-degree bends in it, which, although it doesn't matter that the drive pipe is in an exact straight line, obviously it's going to be important and more efficient if there's no big 90-degree bends immediately upstream of the pump, because hydraulically that's creating a lot of turbulence, which reduces the way the water enters the pump and therefore the pump efficiency. Oh, sorry, I said 1.8 meters for this maximum pressure immediately upstream, it's actually 1.5 metres. So the maximum pressure upstream is 1.5 metres. And in our situation, we've got 1.2 metres. So, yeah. If there was, we've actually also relocated the pump slightly so that it's out of the way should there be flooding. It's much more protected compared to the original location. So operation and maintenance requirements, obviously the replacement rubber cups and diaphragms, which cost about, let's say it was 30 or 40 Australian dollars. So that's pretty much the same as the US dollar, and that was for 2 diaphragms. And the rubber cups actually could be made locally if you've got that availability, and I think they're about $5 or $10 for rubber cups. They're pretty cheap to replace them. The operation and maintenance to remove the Glockman pump prior to flooding events so that you protect that pump should a flood come down and wash it away. Checking the intake structure, and pretty much they are a low maintenance system, and certainly low maintenance in terms of cost as well as time. Any questions on that before I finish up?
Victoria.
Yeah.
I have a question, maybe with your experience. Here in Pakistan there is a lot of canals built by the government or the farmers to take the water from one place to the other. Do you think this pump can work in those canals that flow the water?
Yes, it would actually be
yes?
quite a good solution for them, because a canal usually has quite a low hydraulic grade, and these wouldn't require too much extra drop to make them work, and you could just even put them into the canal, just drop them, especially if there's a no top on the canal, you could just drop them into the canal.
Oh, great, great. And how long do you think we can pump the water? Not in altitude, not as in distance, we can pump this water.
The main consideration is actually the height. So in the situation we had here, it was lifting about 50 metres, and the distance was about 900 metres.
Oh, great, great. And then with not much different, and the level can flow longer than 900 meters. Yes.
I think the bigger influence is the elevation. So the height between the pump and the tank has more of an impact than the distance. The other thing to consider with these pumps is that they don't, on the delivery line, any air in that delivery line will stop the flow. So if you've got a delivery line which is on a constant incline, that's good. If you've got a delivery line which either goes up, then down, then up again, up to the tank, that's going to create problems. And you'd have to consider some sort of air release valve if you've got a change in grade on that delivery pipe.
Okay, okay, good, good. Thank you.
All right, any other questions before we finish up? Okay, well, thanks everybody for participating in our webinar, and thank you to Oscar for helping with the facilitation and the presentations, and I'm also really looking forward to seeing it uploaded onto eNet, and please feel free to pass it within your networks to anyone that might be interested in listening and watching. So thanks everybody, have a lovely afternoon, evening, morning, whatever it is that it happens to be at wherever you are. So
thank you, Victoria, for leading. Thank you everyone for listening us as well. Have a good day.
Thank you.
Yeah, thank you everyone.
thanks.